And now it's time for an episode of How Things Work. This week we are looking at, I thought this would go quicker, linear stuff. I'm calling it linear stuff because you've heard a lot of different terms for it. Linear relations, linear equations, linear relationships, linear functions. We're just talking about linear things. So, the first thing to talk about when looking at linear stuff are our variables. In math, science, sports, farming, meteorology, life overall, etc., there will always be things that change. Things that can be measurably changed are called variables. So, for example, the amount of sunlight in a room and how much money is in my wallet, these are both examples of variables. They can be changed, they can be measured, but those two particular variables don't really have much effect on each other. If I were to go, if I take money out of my wallet, have less in there, the room won't get darker or it won't get lighter. So my money is not affecting how dark or light it is. Also, if I open up the window, I won't magically find more or less money in my wallet. So even though I can measure both of those amounts, they don't affect each other. Or do they? No, they don't. Not at all. When two variables do affect each other, however, we say that there is a relationship. So there is a connection between those variables called a relationship. Sometimes this relationship is so predictable that we can even write a rule to describe what will happen before it even happens. So let's talk about independent and dependent variables. When two variables do affect each other, one is normally causing the other one to change. So, for example, just because my plant is tall doesn't mean the sun will be out more. However, if the sun is out more, my plant will get taller. So the amount of sunlight does affect the height of my plant. The height of my plant does not really affect the sun. So we would call the amount of sunlight the independent variable because we either have control over it or it kind of acts as its own. So that one is independent. It's what kind of changes on its own or what you change. Now we would call the height of the plant the dependent variable because it depends on the amount of sunlight. So height depends on sunlight. Height is dependent. Sunlight is independent. So what makes something linear? What calls or makes our relationship be considered linear? If some variable is constantly changing by the same amount. This would be linear. This amount that we are changing by may be written or thought of differently, but it's always proportionally the same. Now, when I say proportionally the same, why don't I just give you an example to show you what I mean? So, for example, if Sally is getting paid $14.50 per hour, well, I could also say she gets paid $7.25 per 30 minutes. I could also say that she gets paid $29 per 2 hours. I could also say that she gets paid $145 per 10 hours. I could also say that she gets paid so on and so forth. Notice, all of these rates are the same. $14.50 per hour is the same as $7.25 per half hour or for 30 minutes. Okay, both my time, hour, 30 minutes, that was halved, and $14.50 to $7.25, that was cut in half as well. Or from my original here, I could double them both. Hour to 2 hours, $14.50 to $29. Okay, so proportionally speaking, all of these rates are the same. So as long as her payment is always kind of considered the same proportionally, we would call this a linear relationship between the time, hours, and the money. Slope. This constant change that we are talking about can be called the slope of our linear relation or our linear equation or our linear expression or our linear function or our linear relationship. Whatever you are calling it, whatever it is that is linear, that change, that rate of change is called our slope. Now we think of the slope as a rate. that uses the independent and dependent variables. So in our example, the rate was $14.50, so money, per 1 hour, time. We are comparing two variables here, the money and the time. Now you can't buy more time, but over time you can make more money. So this makes the time the independent variable, it changes on its own, and the money the dependent variable. The amount of money depends on how much time has gone by. So when we write our slope, or again remember it's our constant rate of change that is proportional throughout, we will write it as a ratio or a fraction with the dependent variable over the independent variable. Or I guess more appropriately we would say the change of the dependent variable over the change of the independent variable. I'm sure you've heard me say before that it's the change in y over the change in x. The y-intercept, or the constant term. Many relationships will have a starting point. So in our example with Sally's money, Sally may have already had $33, and now she's just working to get more. This extra $33 is a constant. She will always have, or she already has, and it's not affected by the independent variable. As time moves on, well, she'll always be able to look back and say, I had my $33. Even if no time has gone by, she has $33. If 1 hour has gone by, well, she got more, but she always started or still had that $33. So the independent variable does not affect this piece. So this starting point can be called the y-intercept. That's if you're thinking of it in graphical terms, or you can think of it as a constant term in mathematical notation. So a constant term would be this one here. Notice it doesn't have a variable to go along with it. All of these other pieces, x squared minus 7x plus 3x squared plus 3x, they all have a variable going along with them. This one is just simply a number, just 9, just hanging out there, constantly being at least 9. All of these ones, if I plugged in x is 0, well, they're no longer there. But this one will constantly always stay as the 9. So this piece, where there is no variable, is our constant term. All these other ones have different names as well. This 3x and negative or minus 7x, these are called our linear terms, because when your rule or your equation or your relationship or your function, whatever you want to call it, when it has a spot where there's a 3x or a negative 7x and there's no squared along with it, this is what makes it truly linear, are these pieces. So these are called linear terms. This is a constant term. These last two are called quadratic terms. They're kind of our x squared terms. If you ever see these in a mathematical expression, you know that it's going to be a quadratic, or make that parabola shape. Whenever you see these in an expression, you know it's going to make a straight line, or linear term. And this one is just along for the ride. It's constantly there. A linear equation. So any linear quote-unquote equation is just a mathematical rule for describing how the change in one variable affects the change in another variable. So the most common one that we will ever see or work with is this y equals mx plus b. We usually call it the slope-intercept form because, hey, here's our slope, hey, here's our intercept. Now remember, we've been talking about how y is like our dependent variable. It depends on x, which is our independent variable. We've been talking about the slope here as how much the dependent variable changes when the independent variable changes. Change in y over the change in x. So again, if we think about our slope with Sally, she got $14.50 per 1 hour. So how much did the dependent variable change? How much did money change? Well, it went up by $14.50 when the independent variable, or the time, changed by an hour. So as 1 hour goes by, the money goes up by $14.50. Oh yeah, And by the way, there was this constant $33 that she always had. Now another thing to talk about are just points, ordered pairs, or we can think of them as data. Any given part of the, or at any given part of the relationship, we can check to see how much of the independent variable has affected the dependent variable. The measurements or information that we're going to see is just data. This data gives us two pieces of information, or two numbers, how much of the independent variable there is, and how much of the dependent variable there is. Now that might sound kind of goofy, so let's think about that in our Sally example. If we wanted to check in with Sally after she's worked for maybe 13 hours, we would see that she has $221.50. That's in total. So let's see how that worked. 13 hours of work at a rate of $14.50 per hour. Now that $14.50 per hour at 13 hours was $188.50, just gained by working. But then we have to add that on to the $33 she already had, so we get a total of this. So notice, the independent variable changed by 13. We went 13 hours later. In the end, the dependent variable changed to 221.50. We could write this data as the point. 13 is our x value. 221.5 is our y value. Time and money. At any given moment, we can see exactly, oh, here's independent, here's dependent. I get two numbers when I'm checking at one particular moment. So remember, linear stuff. Ways to see all of your linear relationships? Well, we can look at tables, we can look at graphs, we can read about them in word problems, or we can look at different kinds of equations. And remember, there are multiple different kinds of equations. Things that you will see in all of those is a slope, which is that rate of change, maybe some intercepts, a y-intercept and even an x-intercept, and some points should be around. Now we'll go over all of that stuff in our next video then.